and it is going to be the law of sines and law of cosines. And before we get into the law of sines and the law of cosines, I first want to go and visit the area of a triangle. And I want to give you a different formula for the area of a triangle. So we all know that the area of a triangle can be written as area A is equal to 1/2 B multiplied by H. But sometimes not every triangle has a very clear height. So if I drew this triangle right here, we call this triangle ABC, and then we give some side lengths some names. So we're going to call this side here little a, the base here little b, and the final side little c. The height of this triangle is right here. And so if we wanted to use our classic formula of area equals 1/2 base times height, we wouldn't always be able to do that. So today we're going to look at a different formula on how to find the area of a triangle. And the area of a triangle is the following. You can take 1/2, so the area is equal to 1/2 two of the sides. So we're going to take side A and side, let's say B, and then multiply that by the sine of the angle between the two A and B. So notice here that C is in between A and B. So that's a different way you can find the area of a triangle. It's 1/2 AB multiplied by the sine of C. And so this gives us three different ways to write the area of a triangle. Another way we can write area is equal to 1/2. Well, we can do BC as well, and I'll color code these here for B and C. And then we got to multiply that by the angle that is between B and C. So that's going to be the sine of A. And then finally, we can do our final two legs. So the area is also equal to 1/2. All we have left now is A and C. And the angle between A and C is angle B. So we're going to multiply that by the sine of angle B. So right there is angle B, and we'll multiply that out right there. So that's a different way that we could find the area of a triangle. Why don't we put that to the test real quick? So we're going to find the area of this triangle. There we go. That is not a triangle. All right, so we have this triangle here. Once again, we're just going to be really simple in our naming. We're going to name it ABC, and we're given that angle A has a measurement of 135 degrees. We're given a couple of side lengths, so we know that AB is equal to 17 and AC is equal to 19. Looking at our formula here, all we need is two sides and the angle between those two sides. And we have all of that information. So now let's just plug that into our formula. So we're going to take the area is equal to 1/2 17 multiplied by 19 multiplied by the sine of the angle between them, which is 135 degrees. And so if we multiply 17 and 19 out and then divide that by 2, we're going to get that is equal to 161.5 multiplied by the sine of 135 degrees. And just real quick, make sure when you're calculating out your sine and cosine that you have your calculator in degrees. I got a couple of emails last time saying that, oh, this wasn't working. It's because your calculator was in radians. So if we have our calculator in degrees and we take 161.5 multiplied by the sine of 135, we're going to get that the area is approximately equal to 114.2. I'm going to rewrite that too. I don't like it. 0.2 square units. All right, so all you really need is two side lengths and an angle between them. Pretty straightforward process. So now that we have that in mind, a different way to find the area of a triangle, why don't we move on to something new? This is going to be theorem 9.9. And this is going to be the law of sines. And the law of sines can be written in a couple of different forms. So we're going to have a triangle here. We're going to call this triangle ABC, just like we do every triangle. And we're going to give the smaller, lost my train of thought. We're going to give these legs also names, so little a, little b, and little c. And the law of sines can be written in two different forms, and this is the law of sine. So the sine of A, so the sine of angle A, divided by the leg small a is equal to the sine of angle B divided by little b. So we have a ratio. The law of sines is a ratio. And that is also going to be equal to the sine of C divided by little c. And the different way that we can write the law of sines is put our little a on top and our sines on the bottom. So these ratios right here are the law of sines. And now we can use the law of sines to find some missing angle measurements. So we're going to go ahead and solve this triangle. It's going to be triangle ABC again. And we're going to use the law of sines to find one of our missing angles. That's also not a triangle. You know what? I can make this one into a triangle if I just drag that down straight. Never mind, I can't. Sometimes this software is super finicky. All right, there we go. So we have this triangle here, triangle ABC. And we also have our law of sines up above. And we're going to give that angle A is equal to 135 degrees. We're also given that AC is equal to 11, CB is equal to 20, and our final unknown side is equal to C. So we have to find side length C, we also have to find angle C, and we also have to find angle B. Why don't we use the law of sines to find the measurement of angle B? And so we know that the sine of angle B divided by the length of side B, so that's the leg that is opposite, is going to be equal to the sine of angle A divided by the length of leg A. So that's going to be the 20 over there. So why don't we plug in those numbers? I'm going to get rid of this purple arrow there. And so we don't know the sine of B. We know that little b is equal to 11. And we also know that the sine of A is 135 degrees. And we know that little a is equal to 20. And now we just need to solve for the sine of B. So the sine of B is going to equal 11 times the sine of 135 divided by 20. And if you plug in 11 times the sine of 135 divided by 20 into a calculator, that will approximately equal 0.4984. So now we know that the sine of b is equal to approximately 0.4984. And going back to our lesson that we did last time, we can find the measurement of angle B by using an inverse trig ratio. So if we take the inverse sine of 0.4984, that is going to give us approximately 29.1 degrees. And now it's rather straightforward to find the measurement of angle C. The measurement of angle C is going to equal 180 degrees minus 135 degrees minus 29.1 degrees, and that is equal to 35.1 degrees. There's an error in my formula, isn't there? I'm just thinking about this because if you add up your 2.1s, you're gonna have a 0.2, but we never take care of that. So that's 180 minus 135 minus 29.1. That's going to be 15.9. I looked completely at the wrong thing the first time I did this. There we go, 15.9, error fixed. Moving on, we're going to also have to use the law of sines to find little c. Except this time, instead of having the sine on top, we're going to have the sine on the bottom and our leg on top. So we're going to say that c divided by the sine of c is equal to 20 over the sine of 135. And I just found where another mistake in this problem. This is a sine of 115, so making brilliant mistakes all over the place. Happy little accidents. The math is still all correct. I just wrote down the wrong number. And so if we now solve for this, we know that the sine of, oh, how did that just scroll up? We know that angle C is equal to that 15.9. So we're going to replace sine of C with 15.9. And now we can solve for C by doing the following. So why don't we multiply the sine of 15.9 across? So C is going to be equal to the sine of 15.9 multiplied by 20 divided by the sine of 115. So if we plug that into our calculator, the sine of 15.9 multiplied by 20 divided by the sine of 115, make sure we are in degrees, not radians, that is equal to 6.04, which doesn't make a bunch of sense. I think I have an error somewhere. Why don't we move on? Where is my error in here? This is rather frustrating. You know, I copied these examples straight from a textbook, and I don't think I was gonna have that error, but here we are. I'm gonna recheck my top here. All right, so my math is correct up to this point, and then the inverse sine of our answer is equal to 29.9 degrees. There's my mistake. right there, 29.9 degrees. And then if we take 180 minus 135 minus 29.9, we get 15.1. And then we would have to replace the 15.1. So it's all right. Sometimes you make mistakes. Life goes on. Sorry about that. Next, we're going to do a very similar example because of that botched first example. We're going to solve triangle ABC again. And here's triangle ABC. We're given the following information. We got A, B, and C. Angle C is going to be 107 degrees. And angle B is 25 degrees. And we're given some side lengths here. We know that AC is equal to 15. Then we're going to have a little a and a little c. So that first example we did, we had two missing angles and one missing side. This example, we're going to have two missing sides and one missing angle. Well, that final angle measurement, angle A here, is really straightforward to find. We're just going to take 180 minus 107 minus 25 to get angle A equal to 48 degrees. So that was a really straightforward process to do that first one. And then we're going to have to use the law of sines to set up our missing side lengths. So let's look at our law of sines. If you want to do sides, put your side on top. If you want to find angles, put your angle on top. So we know that A divided by the sine of now angle A, which is right here, 48, is going to be equal to B, which is 15, divided by the sine of B, which is 25, which is equal to C divided by the sine of 107. So now we can set up two different formulas. We have this formula on the left to solve for A, and we have this formula on the right to solve for B. Both of them are going to use that middle bit. So A divided by the sine of 48 is equal to 15 divided by the sine of 25. And the 15 times the sine of 25 is going to be equal to C divided by the sine of 107. And so now let's solve A first. A is going to be equal to 15 multiplied by the sine of 48. We're going to multiply that sine across on both sides and divide it by the sine of 25 to get A approximately equal to 26.4. And now C, we're going to multiply the sine of 107 across. So we got 15 multiplied by the sine of 107 divided by the sine of 25 is equal to little c. And a little c, when you plug that into a calculator, is approximately equal to 33.9. All right, so that is the law of sines, those ratios there. Next up, we have the law of cosines. The law of cosines is going to look very familiar. So we got theorem 9.10. This is going to be the law of cosines. And if we have any old triangle here, triangle ABC, and we name the sides little a, little b, and little c, the law of cosines is for finding missing side lengths. So it's going to look exactly like the Pythagorean theorem. We're going to take a squared, all right, is going to be equal to b squared plus c squared. The only thing different is you add on 2 multiplied by the two sides in the inside, so BC, multiplied by the cosine of the angle associated with the side you want to find. So a squared is equal to b squared plus c squared minus 2bc cosine of a. And this is applied to all of the sides. So b squared is going to be equal to a squared plus c squared minus 2ac multiplied by the cosine of angle B. And c squared is going to be equal to a squared plus b squared. So this is the part that looks just like the Pythagorean theorem, except we're going to tack on minus 2ab cosine of c. And now you can use a combination of the law of sines and the law of cosines to solve triangles really, really quickly. And so why don't we go ahead and solve this triangle? So here's our triangle. Once again, triangle ABC. And angle B is going to be equal to 34 degrees. And we're giving some missing lengths here. So we have 11, 14, and B. Why don't we start by solving for our missing side length B by using our law of cosine right here. So B squared is going to be equal to A squared, which is going to be 11 squared, plus C squared, which is going to be 14 squared, minus 2 multiplied by those together, 11 and 14, multiplied by the cosine of angle B, which is 34 degrees. And so B is going to be equal to 11 squared. So we're going to take the square root of the whole thing, right? Because we got to get rid of this square. 11 squared plus 14 squared is 317. And then 2 multiplied by 11 multiplied by 14 is 308. And we're left with a multiplying of a cosine of 34. And if we go to the calculator, type in the square root of 317 and minus 308 sine of 34, we are given that B is approximately equal to 7.9. And now we only have to find one angle measurement using the law of sines, because once we have that one, we can just plug into the 180 formula to get the other one. So why don't we use the law of sines to find angle A? And so remember that the sine of A over A, which is 11, is going to be equal to the sine of B, which is 34, divided by little b, which we just found to be 7.9. And so the sine of A is going to be equal to 11 multiplied by the sine of 34 divided by 7.9. All I did was multiply that 11 across the equation. And if you plug this bit into a calculator here, you get that the sine of A is approximately equal to 0.7786. And now we have to use our inverse sine. So sine inverse of 0.7786 to get the measurement of angle A. And we're given that the measurement of angle A is equal to 51.1 degrees. And now we just have to plug everything back in to find our missing angle C. So the measurement of angle C is going to be equal to 180 minus 34 minus 51.1, which is equal to 94.9. And that checks out. Angle C definitely is our largest angle. So that is that. I got one last example for you all. This one's going to be a doozy. So every example we've done so far, we've been given at least one angle measurement and at least two side lengths, or we've been given at least two angle measurements and one side length. What if we're given no angle measurements at all? So let's now solve triangle ABC once more. I knew that one wasn't going to make a triangle. Then that one doesn't apparently either. Make a triangle. There we go. So we have triangle ABC here. And we're given just the side lengths. So this one's equal to 12, this one's equal to 20, and this one is equal to 27. So we have to find all three missing angle measurements. We can find our first angle measurement by using the law of cosines. So let's use the law of cosine to find the measurement of angle B. So we know that B squared is going to be equal to A squared plus C squared minus 2AC multiplied by the cosine of angle B. And this cosine of angle B right there is how we're going to find our first angle measurement. And then from there we can use the law of sines, it'll be a lot quicker. So B squared is 27 squared is equal to 12 squared plus 20 squared minus 2 times 12 times 20 multiplied by the cosine of our missing B. And so the cosine of B is going to be equal to 27 squared minus 12 squared minus 20 squared. All right, so we subtracted those across. And then we're going to divide by that. Then we're going to divide by 2, 12, and 20. And so we're given that this is equal to, let me go to the calculator and type that in. It's going to be a second. I did really shorthand on my notes, unfortunately. So 27 squared minus 12 squared minus 20 squared. And we're going to divide that by 2 times 12 times, 2 times 12 times 20. I messed up typing that in. I need to put some parentheses in there, so let me retype it in now. So 27 squared minus 12 squared minus 20 squared divided by 2 times 12 times 20. And so the cosine of B is approximately equal to 0.3854. And then if we use the inverse cosine of 0.3854, we're given that the measurement of angle B is equal to 112.7 degrees. And I will double check that here. So the inverse cosine of our answer All right, there's one mistake. Notice here there is a negative sign right there. So when we divide across, we need to have a negative down here, which is going to turn that into a negative, and then our answer checks out. And then why don't we use the law of sines to find our missing angle A. So the sine of A over 12 is going to be equal to the sine of 112.7 divided by 27. So the sine of A is going to be equal to 12 multiplied by the sine of 112.7 divided by 27. And you're going to get an answer for that. Plug that into your arc sine or the inverse sine and get the measurement of angle A is approximately 24.2. And then finally, to get our angle C, the measurement of angle C is going to equal 180 minus 112.7 minus 24.2, which is equal to 43.1 degrees.